Hi everyone and welcome to the new video. In the previous video I explained how we can program an ESP32 synthesizer. This project was inspired by a Stylophone and we were able to make a fully standalone board that has an ESP32 and audio chip that works with the E2C bus. It was working well and I was using Arduino IDE for that. Today we will go forward and I will show how we can use this board as a MIDI device. Practically it will be easier. We will not need the audio chip anymore and we will not need a speaker. The ESP32 board will send the commands to the computer and you will be able to use this board with any standard app like GarageBand or something like this. Also, because we don't need raw audio editing, I will switch from Arduino IDE to Python. It will be easier. It will be fun. Let's see how it works. First I will explain the schematic, and here I have a piece of good news. Technically you don't need this board at all. You can just take any ESP32 board and connect it to the USB and it will work. But of course with the proper PCB it is easy and you can have proper keys. So how does it technically work? I will show the schematic right now. And as we can see, the logic is simple. Here is the ESP32 board in the center. As we saw on the schematic, I was just using a connector for that. Here we have an audio chip that I will not use for this project. All the ESP32 pins are practically connected as inputs, so I can use it as a piano keys, and when I press the button we can process it on the ESP32. Here I also have a mode LED. Here I have a volume control, and I will show how we can read this data in Python. Interestingly, 4 pins on the ESP32 does not have pull-up resistors, so I added this to the schematic and practically that is it. So as you can see, for this project it is practically the ESP32 and the keys are working as an inputs, and the ESP32 board will work as a MIDI device. It will send the command to the computer. Practically you don't need a special PCB for that. You can just plug an ESP32 board to the USB port and it will work. But with the proper keys it's much more fun, of course. On my GitHub page I have all Gerber files, so you can download them and order the PCB on your own. And now let's switch to Python and see how we can program it. Okay, now we're ready to start with coding. As you saw in the introduction, I will be using an ESP32 board. This board is using a special version of Python called MicroPython. If you never used Python with hardware before, I did a special video about ESP32 and MicroPython, feel free to watch it. And now let's get started. First I will add some constants, like the heartbeat pin, the LED pin and so on. Then I need to specify the pins I will be using for the piano keys. I copied them from the schematic. And for every key there will be 2 states, K pressed and K released. When the K is pressed or released, I will send the specific MIDI command for that. As a reminder, MIDI stands for Music Instrument Digital Interface, and it's a pretty old protocol, but it still works well and we will see how it works. And now I will create the init GPIO method. Here I will initialize all the hardware. First I will initialize the internal LED. Internal LED is soldered on the ESP32. And our LED we can use for heartbeat. I'm also adding this variable as a global so I can use it later. I will be using analog to digital converter to read the volume value. And now, last but not least, I need to initialize the keys. As we can see, the logic here is simple. I have all my pins as a list. And there are special pins that don't have pull-up resistors, so I don't specify pull-up for them. And I will also have an array to store all these pins, so we can read these values. For every key I will also store its state. As a reminder, the key can be idle or it can be pressed. Now I can add this method and I can run the program, but there is no logic yet, so nothing will happen. And now let's go forward. Let's read the keys. Now I'm adding a new method, update keys, and the initial logic will be simple. Our ESP32 board is practically a single core microcontroller, so it's not a full-fledged OS, it runs only one program. So in the infinite loop I will update the keys and later I will send this data as a MIDI, but let's implement update keys first and see how it works. First I will iterate through all my keys. As a reminder, I have 15 keys on the board. If you don't have the same PCB, this code will still work. You can just need to update these pin numbers. And this is the first naive implementation I did. We will see soon why I call it naive, but you can see that the logic is simple. If the key is pressed and the state was idle, the state is changing to K pressed. And when the key is not pressed and it has a stay pressed, then I set it to idle and that is it. I will also have two event handlers, on K down and on K up. With this way I can split the low level logic with high level logic. It is easier to code this way. And as we can see, update keys will run infinitely. So whenever the key is pressed and released, this code will be executed. And I'm also changing the state of the internal LED so we can see it on the board. Let's see how it works. Now I'm pressing the keys. And as we can see it works, but there's a problem here. When I press or release the key, the event is calling many times. The reason for it is simple. As I press or release the key, actually many events are triggered. In the ideal world it should work, but practically the hardware is not ideal. There's a small friction on the keys. When I press it, there's a small bouncing and so on. And instead of one event, we can get 10 events or something like this. We can easily fix it in the software, and the method is called Debouncing. The logic is straightforward. I just need to ignore the event if it happens too often. For example, if key was pressed and released immediately, I can just ignore this event. First, I am adding extra state K released. If the key was released but then it was pressed again, I will just not generate K up event. Second, I will add the parameters for the debouncing interval. Our update keys method will be a bit more complex. I'm removing the old code. First, I'm getting the current time, and I need to know the interval since the last K change. And as we can see, the logic is simple. If the K state was idle, then the K state is changing to K pressed, and I also save the current time. And only after that I can generate on K down event. And if the key was released but it is pressed again, then I set state to K pressed again and I don't generate this event anymore. So a very short interrupt will be just ignored. And the similar logic will work for the K release. Only if the key was released and the interval is long enough, I will generate the event. Now let's run the code again and see how it works. And as we can see, it works perfect. I'm pressing different keys and the events are coming. Now the keys are working, but as we can see, something is missing. Let's update the LED. Now I will add the method show heartbeat LED. And as we can see, I'm using the heartbeat step, and it can have two states. And they have two duration values. And when the time interval is bigger, the state will be changed and the new time will be saved, and practically that is it. The logic here that this method is not breaking the main loop. So I can just add this method call to the main loop here. It is practically a bit similar to a custom async.io loop. We have the main loop and we update the keys and we update the heartbeat. I'm also adding this heartbeat state so it will be saved. And now let's run it and see how it works. And as we can see, it is much better. The LED is blinking. And now I'm pressing the button, and as we can see, the events are generating. Now we're ready to use this board for playing music. Congratulations, the most complex part is done and the last part is simple. We only need to send MIDI commands. And for doing this, first I will add several constants. Here I'm adding two MIDI commands, note on and note off. And the base MIDI note has a code 60. As a reminder, we have these piano keys. First key will be 60, second will be 61, and so on. Now I'm adding the method send MIDI message. And as we can see, I am just sending the values to the serial port. And now I only need to add these commands to the K up and K down. Practically it looks like this. I'm calculating the MIDI note and I'm sending the command node off with amplitude of 0. And the send logic is for K down. As we can see, I'm using the amplitude from the analog to digital converter and I need to change the values range. After the update keys, I also need to add the method update volume, which will read these values from the ADC. And now I can run the code and we can see our extra values. And now my board will send only MIDI messages. The ESP32 has only one USB serial port, so I need to remove the print, otherwise MIDI messages will be corrupted. Now I'm running the code again. And as we can see, it works, but obviously I hear no sound. To do this, I need to run a separate program to my PC that will receive these commands and send it to MIDI interface. And now our coding part is done. The only thing I need to do, I need to forward the MIDI messages from the serial port to the real MIDI interface. And for doing this, I will be using a program SerialToMidi bridge. You can find it on GitHub. First, I need to close Tony IDE, otherwise the port will be busy. Now I'm running this program on my computer. And as we can see, it is a pretty simple program, but it works well. Here I specified my serial port, and here I specified the MIDI bus that is available on my computer. And as we can see, the app is running. And when I'm pressing the keys on my board, I can see the events. But obviously I hear no sound yet. And to do this, I need to use any MIDI app I want. I'm using Mac OS here, so I can open the GarageBand. Let's see how it works. And now I am opening the GarageBand on my Mac. If you're using Windows or Linux, you can use another program. I am not a musician and I'm not really familiar with this app, but I can press the buttons and it works. GarageBand is a powerful tool and they can also change the instruments. I'm not a musician, so not judge my musical skills. We can also easily test if the sound volume works. Okay, now everything works and you can actually use ESP32 as a MIDI instrument. You may wonder what is the next step and how can you make a real device. And here there are two options. First, you can just take the ESP32, connect the breadboard and the wires and everything will work. As a second and more interesting option, you can open the GitHub page, the link in the description below, and you can download the KiCad files. There is a special folder with the Gerber files, and you can just zip these files and send it to any PCB manufacturer, and for $20-30 you can get a real PCB that you can use. And optionally, if you want to change something, you can edit files in KiCad first. KiCad is an open source project and you can install it completely for free. And then you can export project to Gerber files and send it to production the same way. And as we can see, the ESP32 is a powerful device. You can generate the audio on the board itself, or you can just send MIDI commands. You can program it in the Arduino IDE, or you can program it in Python. And if you want to see more features, write in the comments below and maybe I will make a next part. And that is it for this video, thanks for watching. The Python source for this project is available on my Patreon page. The Gerber files are available for free on GitHub. Both links are in the video description. Press like and subscribe if you want to see more videos like this. I hope you learned something new. Thanks for watching and see you next time.